Hi Doctor, we are Group 4 and in this video we will present the experiment 4 which is tray dryer. My name is Susan and my group members are Ling, Xian, ZHEN, Muhammad, AIMAN, IKMAL and Ryan Johnson. In this video, I will present the part of introduction. First, background of experiment. As you know that drying is a mass transfer process consisting of the removal of water or another solvent by evaporation from a solid, semi-solid or liquid. A source of heat and an agent to remove the vapor produced by the process are often involved. This process is often used as a final production step before selling or packaging products. Adjustment of moisture levels in solid materials can be a crucial step in chemical processing and can help lower the cost of transportation and storage by removing unnecessary liquid volume in a material. Drying methods and processes can be classified as batch, where the material is inserted into drying equipment and drying proceeds for a given period of time, or as continuous, where the material is continuously added to the dryer and the dried material is continuously removed. During the drying process, two fundamental and simultaneous processes occur. First is the transfer of energy, mostly as heat from the surrounding environment to evaporate the surface moisture, and the second is transfer of internal moisture to the surface of the solid and its subsequent evaporation due to the process. The objective of the experiment are to build a typical drying curve using a laboratory scale tray dryer and to analyze the effects of drying processing parameters on the quality of dry product based on the drying curve built. The scope of the experiment. After drying the solid experimentally using a tray dryer, we need to analyze the experimental data relating moisture content to time, and it should be represented by a typical drying curve. The study of drying behavior can be carried out further by determining the drying rate of the solid and also by calculating the heat and mass transfer coefficient during the constant rate period.
Good afternoon. My name is Ryan Johnson, and today I will be continuing this presentation by describing the theory behind this experiment, which is drying. So without further ado, allow me to begin this presentation. In this experiment, we are focused on a concept called drying. So what actually is drying? Drying can be described as the process of moisture removal from a solid or solvent. Drying is also a very important process that is used in the industry because we would like to purify a solid material or a liquid solvent before it is being treated in further processing. When we talk about drying, there are basically two main concepts that we will be focusing on. The first of which is evaporation, which is basically the movement of water molecules from a solid surface or from a liquid solvent. And next is the mass and heat transfer, which are a set of equations that basically dictate the rate of drying or how heat is evenly distributed and the behavior of the wet material throughout the process of drying. So in the industry, drying is commonly carried out by passing hot gases over a solid surface or passing it over a liquid or raising the temperature such that water molecules can be removed from a liquid solvent. The rate of drying, which is basically how fast can the drying process occur, is dependent on a few factors such as air velocity, surface area of the material, and the surrounding temperature. In the industry, there are several types of dryers that are being used. And in the industry, it is most commonly found that dryers can be classified based on two types. The first of which is a batch dryer, and the second of which is a continuous dryer. In a batch dryer, a fixed mass or volume of wet solids are actually passed through a tray dryer, where basically arrows in the diagram here dictate the direction of air flowing through the dryer. After a period of time, this wet solid which has been dried will be taken out from the dryer, whereas a fresh batch will be put in. A main advantage of using a batch dryer is that the uniformity or the consistency of the dried products will be uniform and kept constant for all the materials. Whereas for a continuous dryer, the continuous dryer uses a conveyor belt where wet solids will be passed through the dryer continuously, and hot air will be passed over this conveyor belt in a countercurrent configuration. So examples of batch dryers include the tray dryer, and for continuous dryers, we have dryers such as drum dryers where materials through a conveyor belt can be rotated or passed through continuously. The main advantage of using the continuous dryer is that it saves a lot of time, and the time needed for the drying process to occur will be shortened or reduced significantly. So when describing the drying process, there are a couple of equations that we need to know. The first of which is the drying rate equation, which is basically a differential equation that combines the factors that affect how fast the drying process can occur. So in this case, we can see the change in moisture content over time, as well as the total mass of the sample over a given area are basically factors that can affect how fast this drying process can occur. Next of which is the moisture content, which basically determines the amount of water that is present in the sample over its total dry solid mass. Then we have the heat transfer coefficient, which is basically a coefficient that dictates the direction and the behavior of heat transfer. And last but not least, we do have a drying curve for all wet materials when they go through a drying process. So that is the end of the theory part of this presentation. I will now pass it on to my teammates for methodology. Thank you very much.
Hi, I'm Xian. I will present the methodology part for this experiment. The material and apparatus we used in this experiment were tray dryer machine and the tray in the tray dryer, the welding skill in the tray dryer as well, airflow meter and rise. There's an assumption and justification for the experiment because the assumption can make our experiment become easier and to ease our experiment. So the assumption is the humidity, velocity, temperature, and the direction of the air are constant throughout the experiment. So the tray dryer is performed under constant drying condition. These are the experimental procedure. Firstly, the surface area of two metal trays were determined. Then, the mass of two empty trays were measured by using a digital scale that has been installed in the tray dryer. Then, the wet rice were placed on each of the tray, and then the mass of the tray and rice was measured. Before starting the experiment, the airflow was set to the mid position, which is 5, and the temperature controller was positioned to 8. The machine was switched on. Then the setting was constant throughout the experiment. The experimental data were recorded at the regular time interval, which are total weight of the rice in the tray, the wet bulk and the dry bulk temperature at the two conditions, the temperature of the machine, and the air velocity in the machine. Then, after we get the experimental data, the moisture content and drying rate were calculated, and the drying curve graph were plotted based on the experimental data we get. And then this is the safety procedure. Permission was obtained before operating the tray dryer. The tray dryer was turned off whenever we leave the workstation. The instructor and assistant engineer were notified immediately if there was any smell or sound that was out of the place. Any laboratory apparatus should not be removed or transferred to the other laboratory without specific permission from the instructor and assistant engineer. Any electrical modification should not be made in the laboratory. Appropriate attire was a must when conducting the experiment, such as wearing a lab coat, confining long hair, and wearing shoes that cover our whole feet. So that's all for the methodology.
Hi, I'm ZHEN. Now I will present about the calculation and discussion part. So the table 4.1 shows the experimental data of 70 minutes. The weight of the wet rice and dry rice are calculated. Next is the sample calculations for dry basis moisture content. When T equals to 1 minute, the weight of the rice is equals to 250.3 grams, while the WS is equals to weight of the dry rice. The moisture content X can be calculated by equals to bracket W minus WS over WS to get the moisture content. So at T equals to 1 minute, the moisture content X is equals to 0.20048. And the table 4.2 shows all the calculated dry basis moisture content for all the intervals. And based on the table 4.2, we can plot the drying curve, which is the graph of the dry basis moisture content versus time. And based on the figure 4.1, we can find that the moisture content decreases over the time, and the drying process will slowly dry off the wet rice, which causes the reductions of moisture content. Next is the sample calculations for the drying rate. R is the drying rate, while the WS is the weight of the dry rice, and A is the surface areas of tray. So the drying rate is equals to negative WS over A times with the dx dt. And by substituting the value into the formula, we can find that the R is equals to 0.29495 kg H2O over meter square over hours. So table 4.3 shows all the calculated drying rates. Then based on the table 4.3 and 4.2, we can actually use the calculated value to plot a drying rate curve, which is the drying rate versus dry basis moisture content. And based on the figure 4.2, we can find that the drying rate fluctuates a lot as the dry basis moisture content increases. And in the initial phase, the drying rate fluctuates a lot, and it starts to increase steadily until it reaches the critical drying rate, which is the RC. The critical drying rate for this figure is located at the point which labeled as C. Next, I will pass the presentation to AIMAN to continue. Thank you.
Next, to calculate for the heat transfer coefficient, we first need to determine the mass transfer coefficient Q, which we can use the formula RC times A times lambda W. To get lambda W, we first need to determine the average dry bulb temperature and the average wet bulb temperature. And from this average wet bulb temperature, we can get from the steel table, which is lambda equal to 2406.96 kilojoule per kilogram. Then we can use the values obtained to calculate Q, which is equal to 75.8192 kilojoule per hour. And we can calculate the heat transfer coefficient H equal to RC plus lambda W over T minus TW. And we can get the H equal to 429.103 kilojoule per meter square hour Kelvin. Then we need to calculate for the drying time estimation. For constant rain period, we need to determine the T is equal to WS over A times RC times X1 minus X2. And we can determine X1 and X2 from the graph that we obtained. And then we insert all the values and we can get T equal to 0.2825 hour. And next, for the falling period, we need to determine all the lambda delta x times 1 over RAV, and we need to sum all the values that we obtain, and we get 0.32172. Then we can use the values obtained to calculate T for the following period, and we get T equal to 0.6589 hour. And we can calculate the total drying time 0.2825 plus 0.6589, which is equal to 0.9414 hour, which is around 56 minutes. So this 15 minutes is quite different from the 17 minutes, which is the actual drying time that we use. This is due to the fluctuating behavior of the digital weighing scale and drying parameters, which is the speed and the temperature. And the coke rise was also not distributed evenly on the tray, which caused the efficiency of the drying process. So for the first error, the values shown by the digital weighing scale were inconsistent. To fix this error, we need to have a new calibrated digital weighing scale in the lab. And we also need to ensure the rise is distributed equally to the same surface area, because during the experiment, the cook rise was not distributed evenly. And last, the dry bulb and wet bulb temperature is already high at the start of the experiment. So we need to ensure the tray dryer equipment is cooled down first before starting the experiment.
Last but not least, we have come to the conclusion. From this experiment, a typical drying curve is built according to the experiment result. During the drying process, the moisture content of the wet rice in tray dryer decreases over the time. The critical moisture obtained is 0.30943 kg water per kg dry solid, and the critical drying rate is 0.1271 kg water per meter square per hour. From this experiment, the time taken for a complete drying process is 70 minutes, which is longer than theoretical value calculated, which is 56.484 minutes due to some experimental error. And these are the references that we use for this experiment. Thank you.